this video, we're going to graph and also translate exponential functions, which means we're going to get some good practice on how to enter these things into your calculator. So if you don't have a calculator in front of you, press pause right now, go get your calculator, or make sure that you've downloaded the calculator that I've put into your course, the WebIt TI-84 emulator, which is super helpful. Otherwise, just get your normal calculator out and then we can continue. So here are just some good things to remember about exponential functions, and I just sort of put it all on one page so you could look back at it. Again, the exponential function is in the form f of x equals b to the x, where b is greater than 0 and not equal to 1. So essentially I'm saying if I said y equals 1 to the x, it's not exponential because 1 to any power is 1, and so that's actually just going to be a straight line. So that's silly. Also, I want to point out that if I said y equals x squared, even though that has an exponent, that is not an exponential function because in order for it to be exponential, my exponent has to be the variable. The graph of the function, which is what we're going to be doing, we're going to graph it ourselves, then we're also going to look at what happens when we translate that graph. So we're looking at transformations from a couple of weeks ago. The graph is smooth and continuous. The domain, remember that's the x's, is all real numbers. The range is that y is greater than 0. And again, that's for this form before we do any translations. So the range could change based on what kind of transformations that we've done. And again, the graph before it's transformed goes through the point 0, 1. If b is between 0 and 1, so it's some sort of decimal or fraction less than 1, but not 1 or 0, as we said before, then the graph is decreasing, and it's increasing if b is greater than 0. So let's take a look at an example. Again, you're going to want your calculator out for this. I certainly have mine out in front of me right now. And what we want to do is just practice how we're going to stick this in our calculator. So in your calculator, in my calculator, I'm going to take -3. So notice I've just given you some numbers to plug in, and I just made those up, and it's totally fine to do that. So I'm going to plug in 2 to the -3rd. So on your calculator, you're either going to look for a button that looks like this, where you would enter it in as 2xy -3. Keep in mind that has to be a negative and not a minus sign. Or on your calculator, you're going to put 2, and then you might have a button that looks like this, the caret button. And the caret button, again, says make it an exponent. And then I would write -3, keeping in mind that's a negative and not a minus. So 2 to the -3, I get 0.125. Because keep in mind what's happening is 2 to the -3, 2 to the -3 is 1 over 2 to the 3rd. So that's just 1 over 8, and 1 over 8 is 0.125. So you can do it using your calculator or, in your head, but use your calculator just to check. Same thing, the next one I'm going to write 2 to the -2, which would be 1 over 2 squared, or 1/4. Decimal form of 1/4 is 0.25. 2 to the -1 would be 1 over 2, which would be a half. 2 to the 0 is what? 1, because anything to the 0 power is 1. And remember what we said is that it's always going to go through the point 0, 1 unless we start moving it right or left using our transformations, which I'll show you in just a minute. Then I'm just going to keep going. 2 to the 1st is 2. 2 squared is 4. 2 to the 3rd is 8. And now I'm just going to plot these points. So -3, and this is like a really small number, and then -2, and another really small number, and then -1, and another small number. And then when I get to 1, it goes up to 2, and 2 goes up to 4, and 3 goes up to 8. So will I ask you to probably graph these on your own? Probably not a whole lot, but I do want to make sure that you know how to plug these things into your calculator correctly, because you'll have to do that in ALEKS this week. So this is the basic function that I'm looking at for the graph of 2 to the x. Now let's see what happens when I translate that function. So the function that's already graphed right now is the function we just did on the other page, f of x equals 2 to the x. I want to now look at how could I graph this without having to make a table again. And so really what I'm going to look for is those translations that we talked about before. So we had a whole sheet that said, if you do this, it moves to the right. If you do this, it moves to the left, and this flips it over. All of those things are exactly the same. So this guy right here is my h, and remember h was always the opposite sign, so h in this case is actually -2, and this guy right here is my k, and k in this case is 3. And what this tells me is the horizontal shift is -2. So say this point right here, it's going to move 1, 2 places to the left, and then k of +3 says that the vertical shift is 3, so I'm going to go 1, 2, 3, and so this original point now becomes this point. And I can do that for a couple of other points as well, over 2, up 3. I can do that for another point, say this one, over 2, up 3. And then again, all I'm looking at is, can I now make sort of a curve that follows that pattern, keeping in mind here that this evened out at about 0, and so this one's going to even out 3 up from that, 1, 2, 3. So this is where that asymptote is going to be. So if I'm drawing my new graph, it's going to look something like this. And so that was a lot easier than trying to plug in a bunch of points and figure out new values. The other kind of exponential function is actually the natural exponential function, and it uses the value of e. So e is an irrational number, kind of like pi. It is a button in your calculator, so you don't ever have to plug in this value. Just like when we're using pi, you don't want to just put 3.14 because that's not exactly what it is. That's just an approximation. When we're using e, you want to use the e function on your calculator. And if you don't have an e function on your calculator, then you need to find an online calculator or something that has that value. Otherwise, you're just going to get a bunch of stuff wrong and it's going to be super frustrating. So I threw this in here, and I'm not really going to talk about it much. This is as we're looking at more calculus things, which would happen, 2 classes from now. It would be the limit, that is where e came from, the limit as x approaches infinity of 1 plus 1 over x to the x. But essentially what we're saying is it's an exponential function where b is greater than 1, the graph is increasing, etc., etc. So it's kind of what we looked at before, but our base now, instead of being a whole number like 2, like our last example, our base is going to be e. So again, let's practice putting this into your calculator. On my particular calculator, my e button, and it looks like this, e to the x, and it is over top, and this is if you have a TI 83, 84, 85, etc. It is over the natural log function. Woof. ln. So I would have to use my second button first and then do e to the x. And so again, e to the x means I'm going to type e to the x, and then I'm going to enter whatever the exponent is. So this would be e to the -3, so I'm just going to do my e to the x button, and then I'm going to plug in -3 and write down that decimal. And I get 0.0498, really, really small number. I'm going to repeat that process for -2. So again, I strongly encourage you to be doing these with me, because if you're not, then you get to these questions that you have to do on your own, and you're not really sure if your answers are correct. So do this along with me now, so you can make sure your answers match mine. And I'm just going out to 4 places here. When you're doing this question in ALEX, I suggest making sure you read the directions, because they'll tell you how many decimal places to go to if they in fact want you to write out those values, as a table. Once we get to 0, remember anything to the 0 power is 1. and then e to the first, and we already kind of know that that's going to be the 2.71828, so I'm rounding to 3. Then I'm squaring it, 7.3891, and then last one to the third power, and I get 20.0855. So obviously that last guy not going to fit on my graph, and that's okay. I really just want a basic idea of what the graph looks like. So I know it's going to go through here. I know 1 is 2.7, which is maybe somewhere in here. I know 2 is 7.3891, so maybe somewhere in here. And then all of the rest of them are like really small numbers. So if I put in -1, it was somewhere in here, and -2, I keep hitting a button wrong here. Let me recopy my point. -1 was at about right here. I think I'm fat fingering this. -2, -3, so we got a curve that kind of looks like this. So we get the basic idea. So now that we've done that one together, I want you to use what you know about transformations of functions to move the existing graph, which is, of course, the f of x equals e to the x that we just graphed together. I want you to translate it using transformations of functions. So press pause, sketch that really quick, and then press play to see how you did. So here, remember, h in this case would be -1, the opposite of +1. K would be +3. And so that means this point would go left 1, up 3. This point here would go left 1, up 3. And again, just gives us a basic idea of what we can expect to see. Just as before, since k is 3, our function's going to even out here, so it's going to look something like this. Maybe not exactly, but you get the idea. When you're doing this in Alex, it's really easy. You're just going to plot a couple of points and then use the graphing function to connect the dots.